The thrust reverser system is discussed next. Each engine's thrust reverser is powered by its respective hydraulic system. Loss of a hydraulic system renders the affected thrust reverser inoperative. The reverser lever has three positions: full down, interlock stop, and reverse thrust. When the reverser levers are in the full down position, the thrust reversers are locked in the forward thrust position. Before the reverser lever can be raised for reverse thrust, the aircraft must be on the ground and the throttles in the idle position. Moving the reverser levers to the interlock stop position causes the throttles to lock in the idle position. A signal is sent to the respective reverse isolation valve, causing it to open, supplying pressure to the reverser. The reverser then unlocks, and hydraulic actuators move the reverser cowl aft. An amber reverser annunciation appears above the EPR indicator as the reverser cowl unlocks, and all forward thrust reference displays disappear. When the reverser cowl and blocking doors are fully extended, the reverser annunciation turns green and the interlock stop releases. The reverser lever can then be moved upward and aft for reverse thrust. In reverse, the EEC downtrims the fuel control for thrust limiting. An auto stow system is incorporated in the thrust reverser system. If a reverser becomes inadvertently unlocked, the auto stow system automatically sends a signal to open the respective isolation valve, supplying pressure to stow the reverser. Now let's look at a normal engine start sequence. Engine start is initiated by pushing in and rotating the engine start selector to ground. The engine start valve light illuminates momentarily as the start valve opens. N2 and oil pressure should start to increase. A magenta reference bar appears on the N2 indicator whenever the fuel control switch is in the cutoff position, indicating the minimum RPM for fuel on. At 25% N2 or max motoring, the fuel control switch is selected to run. This opens the spar and engine fuel valve and energizes the selected igniter. Initial fuel flow indications during start should not exceed 700 pounds per hour. Light off is indicated by EGT rise, which should occur within 20 seconds from the time the fuel control switch is selected to run. Maximum EGT for engine start is indicated by a red radial line on the inner periphery of the EGT radial. N1 rotation must occur no later than EGT rise. As the engine accelerates to approximately 50% N2, The engine start selector automatically returns to auto, directing the start valve to close. The engine should now accelerate and stabilize at idle. In addition to the start valve light, an ICAS caution message appears if the start valve has not closed. This message blanks all existing caution and advisory messages for 20 seconds. With an engine shut down in flight, selecting the fuel control switch to cut off causes the in-flight start envelope and start reference cursors to appear on ICAS. The in-flight start envelope displays the present altitude and the recommended airspeed range for starting. Altitude and airspeed ranges at 2,000-foot intervals below present altitude are also displayed. If the aircraft is above the start envelope, ICAS displays the highest altitude for which an in-flight start can be accomplished. Now click on the appropriate switches to simulate starting the left engine. Now click on the appropriate Now let's simulate starting the left engine, but this time abort the start if an abnormal indication is observed. Let's simulate starting the left engine again. Let's simulate starting the left engine one more time. Now let's look at the power plant differences between the 757, 767-200 and 300, and the 767ER. Let's start with the 767-200 and 300 differences. All power plants used on the 767-200 and some of the power plants used on the -300 use the General Electric CF6-80. System design and operation are generally the same as the 757 power plant. The primary differences are the EEC, engine indications, and various system values. N1 is the primary indication for setting thrust. There is no EPR indication. Standby indications for the GE engine are liquid crystal displays on N1, N2, and EGT. There are vibration sensors for the fan, low-pressure turbine, and the N2 high-pressure compressor. The EEC on the GE engines uses aircraft and engine data to compute the maximum N1 RPM limit, which is displayed as an amber radial on the N1 indicator. Guarded EEC switches are located on the overhead panel. With the EEC switches selected on, the EEC prevents the engine from overspeeding by downtrimming the fuel control unit. An EEC in-op light indicates the EEC switch has been selected off or a failure has occurred. There is no longer any overspeed protection, and the fuel control unit operates independent of the EEC. Full forward throttle will now produce an engine overspeed. The EEC in-op light, accompanied by an ICAS advisory message, indicates the EEC has failed. Advancing the throttles changes the advisory message to a caution message. When an EEC failure has occurred, or the EEC selected off, the command sector will not be displayed. The maximum N1 reference is now acquired from the thrust management system. EEC failure causes the respective EEC to maintain current thrust until the affected EEC switch is selected off. The respective throttle should be retarded before selecting the EEC to off. This prevents a possible engine overspeed. With one EEC selected off, thrust stagger will occur. The minimum fuel on reference indicator is located at 15% N2 for the GE engines. The maximum starting EGT limit for the GE engines is 750 degrees centigrade and is represented by a red radial line during engine start. The line disappears when the engine stabilizes at idle. Now let's look at the 767 ER differences. The 767 extended range aircraft is powered by two Pratt & Whitney 4060 engines. These engines, like the engines on the 757, use EPR as the primary indication for setting thrust. Two guarded EEC switches are located on the overhead panel. The EEC is powered by an independent engine-driven generator. In the event of an EEC generator failure, an automatic backup source is supplied from a supplemental control unit. Engine operation is uninterrupted. If the EEC normal mode of operation fails, it automatically reverts to an alternate mode of operation. This is indicated by the alternate indicator light and the associated ICAS advisory message. When the EEC is operating in the alternate mode, the auto throttles are inoperative. In addition, there is no overboost protection in the alternate mode. This is indicated by the engine limit protection caution message appearing when the throttles are advanced into the overboost range. However, N1 overspeed protection is still provided. The maximum starting EGT limit for the Pratt & Whitney 4060 is 535 degrees centigrade. Now try some questions.